To be able to find the equation of a circle, we need its centre and its radius. If these are not given, they can often be worked out using geometric properties of a circle. The circle C has a line segment from A, -1, 4 to B, 5, -2 as a diameter. Part 1, find the coordinates of the centre of C. Part 2, find the length of the radius of C. Part 3, write down the equation of C. Part 4, draw a graph of the circle and show the point D, 4, 5. And Part 5, verify by calculation that D lies outside the circle. So Part 1, find the coordinates of the centre of the circle. A diameter is a chord which contains the centre of the circle. The centre of the circle is the midpoint of the diameter. We're going to call the centre H, K. So we're going to take our points A and B, label them x1, y1, x2, y2, and substitute into the midpoint formula. So we end up with -1 plus 5 divided by 2, 4 minus 2 divided by 2. This gives us 2, 1, which we're going to label as H and K. So 2, 1 is the centre of the circle. Part 2, find the length of the radius of C. The radius, or, is the distance from the centre to any point on the circle. So we're going to use the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. So remember, in part 1, we got the centre of the circle to be 2, 1. So we're going to use this point and either point A or point B. It doesn't matter which one. And we label them x1, y1, x2, y2, and we substitute into the formula. So I'm going to go with B, 5 minus 2. So subbing into the formula, we get the square root of 5 minus 2 squared plus -2 minus 1 squared, and that gives root 18. So the radius is root 18. Part 3, write down the equation of C. So for the equation of the circle, we need the centre and we need the radius. And we found the centre to be 2, 1 and the radius to be root 18. So this is our formula for the equation of a circle when the centre is not 0, 0. So we get x minus h squared plus y minus k squared is equal to r squared. So the h is going to be the 2 and the k is going to be the 1. So we get x minus 2 squared plus y minus 1 squared. That's equal to r squared. And the square root of 18 squared just gives us 18. So we get equal to 18. So this is the equation of the circle C. Part 4, draw a graph of the circle and show the point D, 4, 5. So what we want to do is go to our centre point. So here's our x-axis, here's our y-axis, and our centre is the point 2, 1. So we go to 2 on the x-axis and 1 on the y-axis. So we plot our point 2, 1. So we're going to put the compass point, the sharp point on the centre, the point 2, 1. And we're going to open up the compass so that the pencil point is touching off either 5 minus 2 or -1, 4. It doesn't matter which, because each of these points are on the circle. And then we just draw our circle. And check if you used the point B, 5 minus 2, to start. Check that you actually go through the point -1, 4 and vice versa. So here we have our circle. So the circle C and the point D, 4, 5 are shown opposite. So we go across to 4 on the x-axis, up to 5 on the y-axis, and go across and we plot the point D. And notice that D lies just outside the circle. Verify by calculation that D lies outside the circle. From the diagram, it is clear that D lies outside the circle, but we have to verify by calculation. So this is the point D. So we're going to let L be the distance from the centre, 2, 1, to the point D, 4, 5. So this is our centre, 2, 1, and this is the point D, 4, 5. So we're going to try and find the distance between them. So we're going to use the distance formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. And we label our 2 points as x1, y1, x2, y2. We substitute into the formula, we get the square root of 4 minus 2 squared plus 5 minus 1 squared, which gives us root 20. As root 20 is greater than root 18, i.e. the line is greater than the radius, D must lie outside the circle. Alternatively, you could substitute 4, 5 into the equation of the circle, so swapping the x for 4 and the y for 5. And again, you would end up getting your answer to be greater than root 18, which would also verify that the point lies outside the circle. So if you ended up getting equals, so these two values to equal each other, that would tell us that the point was on the circle. And if you end up getting this to be a less than sign, then you would know that the point was inside the circle.